Hi, in this video we are going to do the second application for Laplace transform, and that's how to find the transfer function. So let's go ahead and solve this example. Let's say that you have a system, linear time invariant system, has input x of t and output y of t. The input, when the input was equal to e to the power of minus t ut, the output, the corresponding output was 10 e to the minus t cosine 40 ut. The question is, find the transfer function of the system and its impulse response. Well, first of all, we have to find the Laplace transform from the input and the output. So the input is equal to e to the power of minus t ut. Laplace transform of this signal is equal 1 over s plus 1. And the output y of t is equal to 10 e to the power of minus t cosine 40 u of t. You can use the table, but I'd like to show you, how you do that in detail. Cosine by itself, it's equal like that, s over s square plus 16, because omega is equal 4, you square it here. When you multiply by e to the power of minus t, you shift every s by s plus 1. So you replace every s by s plus 1. So you have s plus 1 and s plus 1 square. And then you have the constant, you multiply the constant here, and here you go, you got y of s. So you have y of s, the output, and you have the input. So transfer function h of s is equal the output over the input. So that's the output, 10 s plus 1 over s plus 1 square plus 16, and the output, the input 1 over s plus 1. So when you flip it, you have s plus 1 over 1. So in general, you can say it's equal to 10 s plus 1 square divided by this s1 square plus 16. It's better to express this as polynomial when you do the transfer function. So s plus 1 square plus 16 is equal s square plus 2s plus 1 plus 16 equal s square plus 2s plus 17. So now h of s be written as 10 s plus 1 square divided by s square plus 2s plus 17. So that will be the transfer function. Okay, now what's left is to find the impulse transfer function. What's the difference between transfer function and impulse? transfer function? Well, the impulse response, it's h of t, which is equal Laplace inverse of the transfer function. That's simple. So now we need to find the inverse of this one. Well, when you look at this transfer function, you'll observe that the order of the polynomial on the top equal to the one of the bottom. This is s squared, the highest order, and this one is s squared. When you have something like that, you got to divide it. So I will express h of s now. I have 10 s squared plus 2s plus 1 over s squared plus 2s plus 17. And when you divide this, you will get the following. Let's just do it. I mean, that's mean 10. All right. 10. And when you divide the polynomial, yeah, what you're going to get? You're going to get 1 minus 16 over s squared plus 2s plus 17. That's what you get. So now we start to do the inverse by finding the partial fraction if you need to. Well, I will write this as 10, 1 minus, what about that? You know this one already, it's s plus 1 squared plus 16. So I'll just write it like that, s plus 1 squared plus 16. And you got a constant number here, so it will be better to be like omega. If this is omega square is equal 16, so omega will be equal to 4. So it's better to have 4 here so you can have the sign. But this 16, you say 4 times 4. All right. So now h of s will be equal 10. 1 minus 4. 4 over, I'm just write again here, so we'll have space. Let's now look at the inverse of this one. If you don't have s plus 1, you have s squared plus 16 and you have 4, that will represent sine omega t, and omega is equal 4 t ut. But now there is shift for s plus 1, shift minus 1, so e minus t. And you got 4 constant, this is your 4. And what about 1? Well, 1, it represents the impulse. The inverse of 1 is the impulse, because the Laplace of impulse 1. And then you got 10 as a common factor here. So this is your h of t. And the problem is done. Thank you.